Hello, and welcome to this presentation using NRP Power Analysis frequency mode. In this presentation, we'll show you how to make frequency mode measurements using the NRP Power Analysis application. This presentation assumes that you're already familiar with the basics of the NRP Power Analysis option. We also assume that you're familiar with using NRP power sensors with the SMA100B analog signal generator. If you're not familiar with these topics, it would be a good idea to watch the presentations using NRP Power Analysis and using NRP sensors with the SMA100B before continuing with this presentation. We'll start by assuming that we have at least one NRP Z8X sensor connected and mapped on the SMA100B. The first step in using the Power Analysis option is to click on the Clock Synthesis Power Sensor tile and then choose NRPZ Power Analysis. This is the main screen for the NRP Power Analysis option. At the bottom, we see slots for up to 4 traces. Each has a different color and corresponds to a different attached sensor or a reference trace. More on this in a bit. Our next step is to use Configure to choose the measurement type, frequency, power, or time, and configure the necessary parameters. We select our measurement mode in the Configure Measurement screen. Note that for each of the 3 modes, frequency, power, and time, many of the configurable parameters are similar. In this module, we'll be making a frequency mode measurement. Power and time mode measurements are covered in separate presentations. We'll explain frequency mode measurements by determining the passband of a filter. We do this by specifying start and stop frequencies and the number of steps between them. The NRP Power Analysis application will then cause the SMA to transmit at each of these steps and monitor the received power at the attached NRP sensor. The application then plots the results on a graph, allowing us to view and measure our filter passband parameters. Let's go through the configuration on the SMA100B. We first enter the min and max frequencies, here 750 and 850 MHz. We then define the number of steps, 200 in this case, and the spacing between the steps. We'll leave this as linear. Note that the number of steps partially defines the measurement speed. The greater the number of steps, the longer the measurement will take. There are also 2 choices for timing, fast and normal. Fast uses an integration time of 2 milliseconds for each measurement step, and normal uses an integration time of 20 milliseconds. This increases overall measurement time, but makes measurements more precise. Lastly, we can set the measurement to repeat continuously or execute a single time. The next step is configuring sensors. If we have more than one sensor, we need to select which sensor we want to use. Other options, such as zeroing, level offset, or the use of S parameters, can also be configured here. To configure the level of the signal, use the SMA level hard key, or set the level in the main SMA100B GUI. To start the measurement, select Start. Note that depending on the number of steps and the timing parameters, it may take several seconds or more before the measurement data is collected and displayed. The context-sensitive menu is an important feature in the Power Analysis application. This can be accessed by either a right mouse click or by touching and holding the screen for 1 second. In addition to shortcuts for starting, stopping, or configuring the application, the context-sensitive menu allows us to switch between measurement windows, configure traces and markers, and save results to a file. Let's go over each of these functions. We often need or want to change the scaling of our results. We can use Configure Diagram to adjust the diagram display. Max and min level can be manually configured, or we can use the Auto Scale feature. We can also enable or disable the grid and change the background color, which affects both the current screen as well as saved screenshots. Depending on the measurement mode, there are multiple windows or views that display our measurement data in different ways. We switch between these views using the Next window in the context-sensitive menu. For frequency mode, we have the Standard view, Marker view, and Full Screen options. In Marker view, we can place markers on our trace and see the corresponding values of frequency and power. You can use your finger or the rotary knob to move the markers on the trace. Up to 4 markers can be placed, and we can turn them on and off using Traces markers in the context-sensitive menu. In the same menu, we can define and configure the different traces. The NRP Power Viewer application supports up to 4 traces, and these are normally automatically assigned to each power sensor as it's connected to the SMA. One common additional trace type is the reference trace. By clicking Save to Ref, we create a reference trace that we can then compare with other traces. Let's look at an example. Let's say we want to compare the passbands of 2 different filters. We run a single measurement on our first filter, and then use Save to Ref to save this as our reference. We then set Trace 2's indication to Ref, and see this trace shown in green as Trace 2. We switch filters, run another measurement, and now we can easily compare the passbands of these 2 different filters. The first one our reference in green, and the second one our current measurement in yellow. One last useful feature. The Power Analysis option allows us to save our measurement results by selecting Save Power Analysis in the context-sensitive menu. Results can be stored as images in a variety of formats, or as CSV files of trace values. Files can be automatically named, and there are numerous options available when saving traces as CSV files. Let's summarize what we've covered. Frequency mode measurements are used to see power as a function of frequency. This is particularly useful when measuring filters, but can also be used with many other devices as well. The basic configuration parameters for frequency mode are the stop and start frequencies and step sizes, but we can also configure things such as measurement times, level offsets, etc. Results of the measurement are displayed graphically on the SMA100B screen as power versus frequency. The Power Analysis application has 4 built-in markers for obtaining numeric results, and traces can also be exported as CSV or screenshots for further analysis or documentation. This presentation covered frequency mode, which is only one of the 3 modes available in Power Analysis, so please see the separate presentations on power and time measurement modes. This concludes our presentation using NRP Power Analysis frequency mode. If you'd like to learn more about NRP power sensors or power analysis, please see the links in the video description. Thanks for watching.